Assalamualaikum and good evening to my lecturer, Dr. Suwaya and everyone. Today, I'm from Group 1 going to present about band stop filter. My name is Azri and AZNOR. My metric number is 0821104440.
My name is NADZMI bin RAZIP. My number is B0821101164.
And my name is Barry Lion Hong, and my license number is B082110236.
My name is MOHAMAD SAIFUDDIN bin ANUAR. My tick number is B0821101316.
Okay, so there's a brief introduction of our list group of four for each member. So we're going to present with the next slide. So the next slide is introduction about our band stop filter. So the band stop filter is a form when a low pass filter and high pass filter are connected in parallel with each other. The main function of the band stop filter is eliminating or stopping the particular band of frequency. The band stop filter is also referred with some other names like band eject or notch or band elimination filter. As discussed previously, for high pass filter, there will be one cut-off frequency. Low pass filter also has one cut-off frequency, but this band and band stop filter have two cut-off frequency. This band stop filter will reject a particular range of frequency which are there in between the two cut-off frequency. It allows the frequency which are above the high cut-off frequency and below the low cut-off frequency. These two cut-off frequencies are determined based on the value of component used in the design of the circuits. Next slide, please. So the next slide is about application of band stop filter. You can see the image on your left is about noise cancelling, digital signal and image processing system, and noise reduction. So in another example is line interference, electric guitar amplifiers, optical communication, radio statics, and bionicle device. For example, like bionicle devices to remove noise detection. My partner is going to present the next slide for me.
So for the procedure part, first we use the multisim as our guideline and as our result. Then we use the equipment such as function generator, oscilloscope, resistor, capacitor, and inductor. Next, we build the band stop filter RLC series circuit by using the multisim software. And so this is the circuit. Next slide. And for the next one, we need to derive the formula for transfer function. So you can see this is the RCL circuit, and V is equal to IR. So for V out, the R we take the impedance of C and impedance of L, so we can get this formula. And for V in is for the whole circuit. So the formula for R, we take the resistance plus with the impedance of L and impedance of C. So the formula of the transfer function is voltage output divided by voltage input, and so this is the formula we get from the derivation. Next slide. So this part is an explanation about type of transfer function, which is the voltage gain, current gain, transfer impedance, and transfer admittance. Firstly is for the voltage gain, is the ratio of the output voltage that appears across terminal pair 2 to the input voltage supply at terminal pair is the voltage transfer function of a two terminal pair network. So the next one is current gain. If you regard current through the component as the input signal and voltage across the component as the output signal, both represent in terms of the transfer function. For that component is impedance, which is the Z equals to Vi. And when we put the value of S equals to 0, the transfer function gain is the magnitude of the transfer function. I out over I in is the current gain. And for next one is transfer impedance. The ratio of the voltage supply to the output terminals to the current flowing at the input terminals when the output is grounded is known as the network transfer impedance. So for the last one is the transfer admittance. is the ratio of the transfer meters acquired when the knot is open to the sustenance obtained when the knot is shortened is the admittance transfer function at each knot of a circuit, a transfer function with the current as the output quantity and voltage as the input quantity. Next slide, please. And for next one, we need to find the zero and pool by using the formula from the transfer function. And the formula S equal to JW. And when we use the value of resistor, capacitor, and inductor, and we able to get the value of zero and pool. Next slide. And for the next one is to calculate the resonance frequency, which is FO. So we can derive from the equation WO, which is the WR minus 1 over WC equal to 0. And we get the WO equals to 1 over cert LC. Then we sub in the value of inductor and capacitor. Then we can find the value of WO. Then after that, we use the WO equal to 2 pi FO. After that, sub in all the values, and in the end, we can get the value of FO. And the next part is my partner.
So for the result, so first thing first, by using the skill that we learned from the past lab, we simulate the circuit by using the multisim or any other software that we and then we obtain the output. We fix the amplitude input voltage Vin, verify the frequency and record the output voltage. So this is the circuit diagram that, for our band stop filter. So as you can see, this is our observations for the V out. We put on the function generator, we put our frequency and the amplitude. We put 2 to get our max output is 2 volt. Next, we take the V out max for the second oscilloscope, and then we get the V out there. So this is for the 100 Hz, 200 Hz, 400 Hz, 800 Hz, and so on. So as you can see, as we can see the result, some for the result, the amplitude need to adjust to get the peak to peak is 2 volt. So after our position, this is our table. So we use 100 Hz and so on to 100 kilohertz. So next is the V out. So this is the V out for the each oscilloscope that we got. And then the AV is the one that we need to divide our V out divide by V in. So as for example, 100 Hz we got the V out is 1.99. We need to divide 2 to get the AV. Okay, next for the AV one, we need to use the formula of 20 log and then the result for the AV. So this is the result. And next for the table calculation, this is the table for the calculation for the both AV and AVDB. So by using the table 1.0, we can plot the datagram using frequency versus for AVDB for the band stop filter. So next is for my partner for discussion.
Okay. For discussion, I'm going to explain again. The band stop filter is a form for communication of low pass and high pass filter where parallel connection instead of cascading notion. We know that for different frequency in the input, the circuit behave either as an open or short circuit. The circuit acts as an open circuit because the inductor and capacitor are connected in series. The mid frequency range to which the filter acts as a short circuit depends on the value of lower and upper cut-off frequency. At lower cut-off frequency, the capacitor acts as an open circuit and the inductor acts like a short circuit. This lower and upper cut-off frequency values depend on the component values. At high frequency, the inductor acts like an open circuit and the capacitor acts like a short circuit. These component values are determined by the transfer function for the circuit according to design. So in the picture, you can see that's for our circuit, band stop circuit. Next slide, please. So in this is the example of bandwidth. So according to identifier, the passband must have the gain of A max and the stop band must have 0 gain. We can measure the passband ripple and stop band ripple as follow using the formula of passband ripple 20 log 1 delta p dB and stop band ripple 20 log omega s and dp, and magnitude p equal magnitude response of the baseband filter as the magnitude response of the stop band filter. Next slide, please. So in discussion, we proceeded a little bit of procedure. The division of we use the firstly calculation for division of transfer function, and then calculate the zero and pass for the pole for the circle. Lastly, we also need to calculate deviate the frequency. Inductor L is an important component of circuit on the same level as resistors R and the capacitor C. The inductor is based on the principle of inductors that moving charge create a magnetic field. The reverse is also true. A moving magnetic field create an electric field. Inductor can also used to produce a desired magnetic field and store in the magnetic field, similar to capacitor being used to produce electric field and storing energy in the electric field. An inductor consists of a coil wire in the circuit. The next slide is going to be presented by my partner.
Okay, so far we observe that in a RC circuit, the charge, current, and potential difference grow and decay potentially exponentially described by a time constant is called tau. If an inductor and a capacitor are connected in series in a circuit, the charge, current, and potential difference do not grow or decay exponentially, but instead sinusoidally. In an ideal setting, there's oscillation with continued identically with a predicted and angular frequency is given by omega equal to 1 over square root LC. So where is V0R and V0C and V0L are the maximum amplitude voltage across the resistor, capacitor, and inductor component with respectively. The omega, where is a driving angular frequency, is this expression. For VR is equal to V0R sin omega t, and VC equal to V0C sin omega t minus pi per 2, and VL equal to V0L sin omega t plus pi over 2. So for this in this assignment, we'll only discuss series RLC circuit. Since the R, L, and C component are in series, the same current pass through them. The current in the circuit can be expressed in the form of Ohm's law as I equal to epsilon naught over Z. Z is the impedance of the circuit is defined as Z of Z equal to square root R square plus omega L minus 1 over omega C open and close bracket to square root 2. So impedance so the impedance of the circuit is a generalized measurement of the resistance that include the frequency dependent effect of the capacitor and the inductor when omega L equal to 1 over omega C, or what in a term of angular frequency as omega equal to 1 over square root LC. Then the maximum value of the current occur when the driving angular frequency match the natural angular frequency at a resonance. So for conclusion, in summarize, the bandstop filter was created by combining the output of a high pass and a low pass filter, with the filter output being the different. It also known as the notch filter. Bandstop filter are second order filter in every case. It has a variety of application in electronic and communication circuit, as we seen here. For example, it may be used to eliminate a band of undesired frequency from a system, enabling for the frequency to flow through with a minimal loss. So the band stop filter are very selective and can be programmed to reject or attenuate a certain frequency or harmonic containing the general electrical noise in a circuit. So that's all for us. Thank you.